Hi everyone and welcome back to my bench. In a previous video I made an attempt to repair this power bank that I found on the flea market, but unfortunately I wasn't able to repair it, so I searched online and figured out that I could probably find a board to replace it, and this is what I found out. This is the LX-LBU2C power bank module that looked kind of similar, and I thought I might be able to directly replace this within the power bank enclosure, and I could replace the battery so I could repurpose the enclosure. But after it arrived, I figured out that yes, it is similar, but unfortunately it doesn't really allow for the exact footprint, and this one has like a USB-C instead of the LED on the top. So I decided that I'm gonna build a new power bank based on this module, and we're gonna enclose everything inside a 3D printed enclosure. If we take a look at the board itself, comes with two output USB connectors and two input connectors, one with micro USB and one with USB-C. Unfortunately, the USB-C is for the input only and it cannot provide output. It's for charging the power bank. We have two connections, so battery positive and battery negative, and this is for a 1S battery, meaning that we have one lithium cell in its series and we can have multiple cells in parallel just to increase the capacity of the power bank. The board itself is rated for 2.4 amp output, so it can do some fast charging. It has a small switch on the side that when we press it, there are 4 LEDs on the board that will indicate the charge level of the batteries. And if we flip it on the other side, there is also a connection for an NTC probe if we want to also connect the probe and measure the temperature of the battery while charging. I'm not gonna use it, so I'm gonna use the board as it is, and I'm gonna try to build a power bank that can be useful for powering projects or charging the phone while traveling. Now, one of the first challenges in making your own power bank is figuring it out the enclosure for the power bank, and luckily I was able to find an enclosure that was already created by Slava Strunov and was shared on the GrabCAD community page. So I downloaded and I was able to print the files. The files themselves consist of several parts. We have the centerpiece that houses the board. So the board goes like this and it's being held in place by friction, if I align it correctly. So this is where the board goes. This is the holder on the side for the 18650s. I'm gonna use the NCR 18650A that I've salvaged before from an old laptop battery. I have 4 of them, so I only printed 2 of the side holder pieces. The batteries will go in like this. These side pieces will screw on to the centerpiece. The centerpiece has an opening on one side and closed side on the other, so we can use that to have the batteries on one side and can be closed. But you could also print this twice and use 8 cells instead. That would double the capacity of the battery. The 2 pieces are then connected with these pillars that are bolted in the middle, and one of the pillars has this opening for 3mm LEDs that you can use as a flashlight, and there is a position for a rocker switch that can turn on that flashlight. For the 3D printed parts, I printed them at home, but if you don't have a 3D printer at home, then you can use the services of today's sponsor, which is PCBWay, and they're a great 3D printing service. Need fast, high quality 3D printing for your prototypes or custom parts? PCBWay doesn't just offer cutting-edge 3D printing. They are a one-stop shop for advanced manufacturing. With industrial quality 3D printers, PCBWay supports FDM, SLA, SLS, and metal 3D printing, so you get the perfect balance of strength, precision, and speed. But that's not all. They also provide CNC machining, sheet metal fabrication, injection molding, and of course PCB manufacturing and assembly. Why juggle multiple suppliers? PCBWay ensures consistent quality, competitive pricing, and fast turnaround, whether you need a single prototype or full-scale production. From aerospace to medical tech, PCBWay helps innovators bring their ideas to life. Visit PCBWay.com today and see how easy manufacturing can be. For the flashlight part of the power bank, there are 7 positions for 3mm LEDs. If we go on the website, we can have a look that there is already a circuit provided for the implementation where all of the 7 LEDs are in parallel, and there is a 22 ohm resistor used in series with all of the LEDs. Now, if we use an online calculator to figure out what would be the current requirements for this resistor, if the supply voltage is 5 volt, which is the output on the USB as per the schematic, and we have about 2 volts drop across each LED, this might be bigger depending on the LEDs. I'm planning to use a red LED, so I'm using 2 for the volts. And if we say that we want about 20 milliamps for the 7 LEDs, we're gonna get that the nearest resistor is the 22 ohm, exactly as provided here. But the problem is that the resistor will be dissipating around half a watt because of the high current. Now we're gonna have 20 milliamps on each of the LEDs, and because they're in parallel, that would be about 140 milliamps multiplied by the supply voltage. That's about half a watt. So to be safe, we're gonna need a resistor of about 0.7 watts, which is relatively high powered resistor. I don't have one, and because I don't have such a high power resistor, I'm gonna actually reduce the current through the LEDs to something like 12.5 milliamps, which should give me a calculated limiting resistor of about 34 ohms. There is no such resistor of 34 ohms, but there is a 39. However, if we combine two 68 resistor, we're gonna actually get a 34 ohms resistor in parallel, and the calculated dissipation is about 262 milliwatts, or because we're gonna have 2 resistors in parallel, it's gonna be about half a watt, which should be below the what's considered safe to use. To verify the functionality of the circuit, I added 7 red LEDs in parallel, so they are all connected in parallel and are powered from my bench power supply using the 2 68 ohm resistors in parallel. If I power this on, LEDs light up with relatively high intensity, which should be enough. And if we take a look at the power supply, you could see that it's using about 350 milliwatts, and it uses about 70 to 80 milliamps of current. That's about 10 to 12 on each LED, as we had anticipated from the calculation. Now, I don't have a thermal camera to show you the temperature of the resistors, but they are definitely warm and they're not dangerously hot to the touch, so it should be fairly safe to have this circuit inside the power bank and use it to provide some red light. What's interesting about the red light is that in theory it shouldn't affect the eyes if you are using it at night in pitch black. If you are outside and watching the stars, occasionally you're gonna need some sort of a light, and any other light other than red will affect the ability of your eyes to see properly, because they have a time where they adjust to accept more light. Red light is the only one that is not affecting the eyes, so I'm gonna be using them to have a flashlight that can output just red light in case I ever need it when we're outside. Now, before we start to connect anything, it is crucial to make sure that all of your battery cells are at the same voltage. So you are not connecting a full to an empty cell, for example, because that would draw quite a lot of current and might even cause a fire. So make sure that you check all of your cells that are to the same or close enough to the same voltage. So we have 4.06 on all 3 and 4.07 on the 4th one, which should be fine. They all came from the same pack, so I know that they're of the exact same capacity. They've been stored, being charged for some time now. I know that they are not self-discharging, so these are good batteries, and that's what I'm gonna use in the pack. Since the board uses 1S configuration, we need to solder all of these batteries in parallel, and I'm gonna use one of the holders for alignment, but for the top, if I use the other, then I'm losing access to the terminals, and that's why I printed these. These are just cutoffs from the bottom, and using my slicer, I added a negative part to basically not print anything from the bottom few layers on top. So I came up with this, and I'm gonna use this to hold the batteries in place while I solder on top of them. Now I know that soldering is not really an optimal process, and you need to use a spot welder if you have any, or if you have access to one. I don't, so I'm gonna actually use wires to solder them together, and then we can have wires coming on the outside to deliver the current to the inside of the enclosure here. I added the spacers in between with a piece of electrical tape just to hold them in place. Now I'm gonna add some flux to the terminals, and I'm gonna try to solder them as quickly as possible, not to deliver any heat to the battery because we can damage it with it. Okay, so that should now be the pack soldered together. Let's check for continuity between each of the cells, and we do. So all of those four are connected together. Same on the bottom. So let's try if we have continuity between all, and we do. So all of those four cells are now in parallel. You probably noticed that when I was soldering on the zinc pads that are from before, where the batteries were spot welded, the soldering was a lot easier than when I was soldering like on this one on the end, directly on the battery terminal. Now that's something that you should keep in mind. If you are salvaging cells from different packs, then it's better to leave at least some of the zinc pads attached instead of ripping them and connecting them again using solder. Now for the ends, I'm gonna use of the exact same wire, but I'm gonna double the wire just so it has some better current carrying capacity, even though I think it's completely unnecessary, but it's better to be safe, and we need to make sure that we're actually adding the wires on the same direction so they can enter the enclosure later on. Okay, so I had to change the solder tip there because I struggled to deliver enough heat to the joints, and it turned out that that previous tip was actually broken. That would explain why I was struggling with the soldering. Let's fix this one. And let's see how they fit within the holder. Okay, so this one needs to go a bit out. And I think that would work nicely. Let's try to add some of the screws in between. Here are two of the pillars that I've added with the screws. Now next is to figure out and solder all of the LEDs on the one that will be the light. I'm gonna start adding the LEDs, pressing them in, making sure to keep the same polarity, so the longer one is the positive. Next, I'm gonna try and bending the legs. Okay, I think that should be okay to solder the first one. I still have the large tip on the soldering iron. Let's see if that's gonna work. I think that's okay. Okay, so here are all the LEDs soldered in. On the positive side, I use a slightly different technique where I've bent one of the legs and soldered across all of the others, then bend the other and solder as far as I could. Now these are all as one piece, so let's connect the bench power supply using the resistor just to confirm that they light up, and they do. Okay, we can now use a drop of glue to secure them in, and then we can place the pillar in the enclosure. The electronics enclosure has a cutout on the side for a 10 by 15 millimeter switch. Unfortunately, I wasn't able to find one that fits exactly, so I'm gonna be using this circular one, but it kind of fits here in the back, but I'll need to remove the pieces that go on the side, and I'm actually gonna glue it on the case. So let's do that. I'm gonna have the links down in the video description for all the components if you want to purchase them for yourself and replicate and build the same power bank, so you don't have to do this. Okay, that wasn't too bad. Let's cut the excess on the other side. Okay, yep, that should be fine. It's sticking a bit on the side, but that's the best I can do for now. Now, before I add the board, I'll need to solder wires to the USB port on the side so I can take 5 volts for the light. I'm gonna add just a tiny bit of solder first. Okay, that should be enough for me to solder wires onto it. Okay, so I'm gonna use just a portion of this wire. Let me double check the orientation of the switch. So it is now into position 1 and it connects these two. Okay, and this, yep, one of them is just not used. I'll need to solder onto the middle one and onto the positive here on the USB. I'm gonna slightly trim this so it's just a short piece. Let's now add some solder to the wire as well as to the center tab on the switch and solder them together. That should be okay. Now let's prepare the wires for the battery. So this is just the same wire. I'm gonna strip it so we can solder it to the board. We should be careful now because we don't want to short the battery pack, because that could deliver quite a lot of current in an instance. I'm trying to figure out, yeah, I'm gonna have to do it a bit shorter than this. Okay, let's cut the excess. And I'm also gonna add solder to the pad. So that's the negative. And this is the positive. Okay, starting to get a bit crammed. Let's connect the negative to the board. Okay, that should be it. Now let's solder the wires for the light. I'm gonna trim this one like so and strip it. Okay, that should leave us with just the negative. Okay, let's add some solder to it as well. And we're gonna then solder it to the negative pin of the USB lead. Okay, that should be okay. Now finally we need to strip the positive side of the battery and connect that to. Okay, the switch is off. Let's add some solder. Moment of truth. Let's permanently attach the power bank with the board. It would have benefited from the larger tip right now, but it is what it is. Okay, not the nicest of joints, but let's see how do we do in terms of closing. That should do. Let's try the LED lights. Okay, that works. Okay, that's good enough. Let's add the screws to the side. And with that, I can now call the power bank done. Let's try and see how it behaves if we try to charge something from it. Okay, so I have my USB tested and we get 5.1 volts on the outside. Let's try and charge something up. I'm gonna first connect this light here. Let's try directly. Okay, that works. I here have one of my other power banks that are just for a single cell 18650 battery. You can see the video up here in the corner for them, so let's try to charge it. Actually, let's try connect through the meter so we know how much current we're drawing. I'm not sure how charged this battery is, but it goes You can see here on the module that it's charging and it's showing about 380 milliamps, 400 milliamps. Next, I'm gonna try charging my phone. Let's see how much current will the phone pull. Okay, so it detected charging, but it's using 400 milliamps, so I think there should be charging info, charging rapidly, so it moved to 1 amp. So the phone is about 83%, so I'm not sure if it's gonna charge any faster or not. Let's try to now charge the power bank. Okay, you can see that that's working as well. It's currently drawing 1.5 amps. So 1.5 amps going in from the charger to the battery. I think that should be decent enough, and we could use the light at the same time. And with that, I'm gonna end the video right here with just a handful of 3D printed parts, a really cheap board, and some salvaged batteries. We managed to create a device that would be really helpful for us to use on our camping trips, just as a source for some additional light, using this small USB modules, or as a power source to charge our devices when we are outdoor, or even more interestingly, with its red light, using it to light up the environment when we are looking for the stars, when we are going outdoors. It would definitely be a useful tool in the arsenal. I'm gonna have links to all of the components that I used, as well as the models for the enclosure, down in the video description. Make sure to subscribe if you like this video, hit the like button. If you have any questions, then leave them down in the video comments, and I will see you all in the next one. Cheers!